One. Um it's In this video I'm going to explain about electrical machines lab 2, uh, experiment number 9, regenerative test. Okay, the another name of regenerative test is Hopkinson test. Okay, Hopkinson test is another useful method of testing the efficiency of a DC machine. It is a full load test and it requires two identical machines which are coupled to each other. One of these two machines is operated as a generator to supply the mechanical power to the motor, and the other is operated as the motor to drive the generator. For this purpose of back to back driving the motor and the generator, this test is also called back to back test or regenerative test. And if there are no losses in the machine, then no external power supply would have needed. But due to the drops in the generator output voltage, we need an extra voltage source to supply the proper input voltage to the motor. Hence, the power drawn from the external supply is therefore used to overcome the internal losses of the motor generator set. Hopkinson test is also called regenerative test. Let's see the experiment. Aim: to determine the stray loss and hence to find the efficiency of the given two identical DC machines. Apparatus required: voltmeter, ammeter, rheostats, and tachometer. Ranges the given. Okay, and this is the circuit diagram. The circuit diagram, there we have it will know there are two identical machines. One is motor acting as a motor, another is acting as generator. This circuit is used to measure the armature resistance, and this is a procedure. Initially what we do should uh, we should switch on that motor, then the rheostat connected to the armature of motor, we should reduce. When we reduce the armature resistance, the speed will increase. At the same time, we should increase the resistance of field rheostat. In both the cases the speed will increase. We must make the motor speed as a 1500 rpm. Once it reaches 1500 rpm, then we should uh, reduce the resistance of the generator field coil. Once if you reduce that, then that voltage what we generated will becomes zero. Once it comes zero, then we should switch on the S2 switch. Then we should increase the resistance of field coil of generator, then to the maximum value, in the sense to get the voltage of 220 volt from the generator. Then we should take the values. And determination of armature resistance. Connections are made as shown in the figure. Keeping the rheostat in cutting position, the supply switch is closed. Rheostat is adjusted to any value of current, and the readings of ammeter and voltmeter noted down. The supply switch is opened. Here I given the experiment demonstration link. But we should be in rated regenerative or back to back test. Here we have used two machines, one acting as a generator, another is acting as a motor. The output of motor is connected to generator, and generator output is connected to the motor. That's why it's called back to back test. Here we are going to use the maximum location. Okay, this is the MCB. once we switch on MCB, then we should switch on the 3-point starter. Okay, the motor starts to rotate. Okay, but we should be in rated speed. For that, we vary the armature restart. When we vary the armature restart, we can measure that speed. The speed goes to maximum, that is rated speed we are getting of the motor. Once it reaches the maximum or rated speed, then on the field restart of generator, see here it shows the value of 135 volt. But you must make it as a 0, so that we are weighing the field restart and field restart generator and see the value of voltage produces and should be zero. Once it reaches 0, then we must switch. That S2 switch should be closed and take the readings of ammeter 1, ammeter 2, ammeter 3 and voltmeter 1 and voltmeter 2. Make the table and do the calculation. Once you start the experiment, you just again change position of armature rear of a motor to its maximum position, then of the motor. Yeah. Yeah. From the meter readings A1, A2, A3 and A4, we should take, and based on that calculations formulas are there. Based on that we should do the calculations. We will get, it's a model graph and the actual graph will get like this. Thus the efficiency of a given DC machine for different loads plotted, and the graph is as a motor and generator. These are the some Viva questions related to that, and thank you.